So most democracies, if they do it right, they follow what's called the cube root law. And this was empirically discovered back in the 70s, and then there was some math that sort of showed why this makes sense. So basically, what the cube root law says is that the legislature should be about the size of the cube root of the population, right? That's kind of the ideal number. And if you look at the most countries, so this is just the OECD countries that are on this graph, there are a lot of sort of gray dots down here. So a lot of countries with small population, see they fall right onto this cube root curve. So the x-axis is people and the y-axis is number of seats. And so if you fall close or near or on this curve, that means you're following the cube root law. That means your seat number is the cube root of your population or close to it. And most countries fall near there. UK and the United States especially are an outlier. So you can see how huge our population is compared to the number of seats we have in the House. So if you had the cube root uh, rule, your Chamber of Deputies would have about 225 seats, provided I just Googled the population of the country, right? It said something like 11 million. Your actual chamber size is about 130. So your chamber is, according to the math at least, is too small. Okay. But still, even with 130 seats, your number of people per representative is about 87,000, which is still good compared to, almost 10 times that for United States. This is actually still a good ratio. So those are just some of the things I wanted to throw out there. I will stop here. I will just say there's a lot of research happening in math and democracy. It's sort of a golden age for this kind of research, from things like proportional representation to AI in democracy, which is a lot of people are talking about that. Direct participatory democracy, things like citizens' assemblies and participatory budgeting, where people get together and decide on something together in a room. Where they get informed by experts and sort of stakeholders, and then they decide on something. They write a recommendation for the legislature. This is more and more popular. It originated in Brazil in the 1980s. A lot of people are just disillusioned with democracy and voting and representative democracy, so they're turning to these mechanisms where people actually have direct voice in some kind of decision, democracy making decisions. So that's what these assemblies and participatory budgeting things are like. Of course, sort of digital democracy, algorithmic stuff. It's all really there's a lot to do and a lot of kind of exciting research that's happening, and I can say more about that if you'd like. So thank you very much for listening. Sorry, I went a little bit over time, but
Thank you very much, Professor Volic, for your presentation. We will now move to the question and answer segment. The question from the audience
great.
will be read by Mariano Ramos. Mariano, please go ahead with the
Sounds
first
good.
question.
Okay.
Let me just figure out how to stop. Oh, there it is. Okay, stop sharing so you're not looking at the. Okay, great. I think I did it.
Well, a lot of the questions are in English, so there will be no problem. But there's one in Spanish, so I'll
Okay.
translate it from Liz Rivera. Well, in Bolivia, we use 63 uninominal circumscriptions, around the half of the deputies. When electoral tribunals or independent commissions have to redraw district boundaries following a census, political parties or maybe a part of the population may disagree in how we should design this. So from a mathematical perspective, what is the most robust or neutral metric or algorithm we can use to declare an electoral map fair and representative beyond simply ensuring that everything everyone have the same population?
Sure. Right. So if you're so you have a combination of multi-member districts and then single member districts as well, right? So when you have multi-member districts, it's very hard to gerrymander. So multi-member districts are actually very good. So if you elect three or more candidates in a district, that's actually a good thing. So this is achieving proportional representation, etc. So it's still possible to gerrymander, but it's much harder. If you have single winner districts, then it's much easier to gerrymander. And one political what to call it solution to this is to have independent sort of groups of people doing the districting. So in the U.S., those are called independent commissions, and only a few states, unfortunately, have them. The rest of the states in the U.S., the legislature draws the maps. And of course, if the legislature is Democrat, they're going to draw the maps that favor Democrats, and the same for Republicans. So having independent commissions draw the maps is desirable. If all that fails, there are various methods, and maybe I'll just quickly show you one more quick time. Sorry, I should have maybe left the slides up. So there are various mathematical ways. Let's see, am I showing? That can look at a district and decide whether it's been gerrymandered or not, or at least flag it as gerrymandering. So there are numerical measures that measure things like wasted votes. So that's one of those is the efficiency gap. They can measure kind of asymmetry and proportionality, how much if tables were turned between two parties, would the other party have the same number of seats as the first party? Then you can look at the geometry of districts, actual shape of the districts, and apply certain measures called the compactness scores. So that has to do with actual shape rather than just sort of the number of votes each party got. And then there's a more sophisticated probabilistic and statistical method called ensemble sampling, where you generate lots and lots of random maps, you study them, and then you compare the map in question to those millions of maps you have generated. And if your map is somehow statistically an outlier in this distribution of possible maps, that's also a big flag for gerrymandering. That's emerging as the most desirable and best tool for sort of detecting gerrymandering. So there's without going into any more details, those are some of the ways that mathematics can kind of flag gerrymandering and warn against it and suggest better maps. So.
Well, we have another question from Milena Carvajal. This is related with AI. How can artificial intelligence complement the use of mathematics in the design and evaluation of electoral systems without introducing a new biases or compromising the transparency of the democratic process?
That's a great question, and I don't have an answer to it. Nobody does, I think, at this point. We are just all trying to figure out what AI is doing. But yes, and there are dangers and possible advantages to using AI. So the dangers are obvious, right? You have this black box that's doing something, right? And so what is it doing, right? How do we understand what these large language models are doing, and how are they giving us recommendations or suggestions? But I think it can be hopeful. So